Greetings. Once again, my name is John Gabriel, and this is a new calculus channel. So I was asked a question by a viewer here. Hello, I'm sorry that my question is a little bit off topic, but I saw you saying in several videos that the circumference of a circle and its diameter have no common measure, but I do not know why it is so. Did Euclid know it, and could you explain the proof? Okay, so first of all, I'm sure Euclid did know it because in proposition 2 of book 10, okay, this is proposition book 2 of book 10, it says, "I κύκλοι προς αλλήλους ίσιν ως τα από τον διάμετρον τετράγωνα," which means circles are to one another as the squares on their diameters. But it's not just that. It's a lot more than that, okay? A lot more than that. So let's just quickly look at that proposition. The first part says that basically that the red circle area to the blue circle area is equal to the red square area to the blue square area, okay? And as you can see, they're equal, and it doesn't matter how I move these, okay? Doesn't matter how I move these. And by the way, I hope you'll notice something while I'm doing this. Okay, let's see. Did you notice when I did that? It's not only a square in this case here, if I'm taking this particular side, okay, or that. It doesn't matter what you do. It can be any particular side. So it's not only a square, as long as they are in proportion. And so that's what the proposition says, but it doesn't just say that. It says a lot more. So what else does it say? Well, because of the symmetry of the circle and the square that is on its diameter, there are a lot more symmetries. So here are the other symmetries. For example, and I've just given you a few, you can say that the blue circle radius to the red circle radius is equal to half the blue square side to half the red square side. You can also say that the red circle diameter to the blue circle diameter is equal to the red square diagonal to the blue square diagonal. What does that mean? So if we had a pen here, the red circle diameter is this whole one here, to the blue circle diameter, this whole one here. I don't know if you can see the pen. Let me do this. Let me just take that off. Okay, so the diameter of the big circle is this, and the diameter of the small circle is this. And of course, if we, let's do this now. If we just move this, oops, I didn't mean to do that. I want to be able to see this. So let's just move it over here. So I said that the red circle diameter, which is this, to the blue circle diameter, which is the whole thing, is the same as the red square diagonal to the blue square diagonal. Does that make sense? Okay. So that's what that is saying. Right. And then, of course, it also says that the blue circumference, the length of this blue circumference to the red circumference is equal to the blue square perimeter, this dotted line, to the red dotted line, all the way including the solid red line here. And there are many more ratios that you can derive from symmetry, okay? So the question states, how is it that they have no common measure? Well, in geometry, they do have a common measure, okay? So for example, if I'm looking at this small circle here, okay, this is a small circle. Let's draw a diameter there like that. Okay, that should go through the blue point, right? So this diameter will measure this circumference 1, 2, 3, and then this little bit here will easily come off here. So it's an exact measure, okay? So it's 3 diameters plus this little bit. The measure is exact. So what happens when we say that the diameter and the circumference have no common measure? We're not referring to geometry, we're referring to algebra, okay? We're talking about algebra. we're saying that regardless of the size of the abstract unit, which is a diameter, we cannot measure the circumference with a diameter. So let's get the pen again. So remember, if this is the diameter, sorry, let me just change that again. If this is the diameter, it's a little skewed, but anyway, you get the drift. And then we have three diameters measuring that. Okay. Then this little bit here has to be in algebra. We have to describe it. We have to describe it in terms of equal parts of this diameter. That's impossible to do. Okay. And I have produced videos with proofs of the incommensurability of pi. There are several of them on my YouTube channel. And of course, there are several proofs also, very, very well-known proofs in mainstream mathematics that show pi it cannot be expressed as a rational number. And the minute you try to describe this last little length with equal parts of the diameter, you fail. Okay. And that's what it means. That's what it means when we say the circumference of the circle and its diameter have no common measure. Okay. Well, they do have a common measure of 3, but there's no other measure to describe this little bit. Now, remember in my previous videos, I was talking about general measure and factor measure. So in geometry, it's a general measure where you say it's 3 of the diameter and a little bit of the diameter to fill this length. So I hope I've been able to explain that to you properly. And if you're not already a subscriber, become a subscriber. I'll place a link to this applet in the details section so that you can download it and play with it. I mean, remember, it doesn't really matter how you move those around. This is all these things here are going to be true, okay? All these symmetries, because the circle and the square have proportional symmetry. All right. So, and that's a word you don't hear using because the moronic mainstream math educators don't understand these things because they've never understood the elements of Euclid. And they don't even know what a number is. They don't even know what geometric measure is or algebraic measure. And they don't even realize that all algebra comes from Book 5 and Proposition 12 of the elements. They're too stupid for that. But in my well-known article called Theory of Fractions from Book 5, I explain all those details. It's mind-blowing information, and I was the first to explain it. I'll have you know that even Euclid didn't write down those things. It's possible that he either thought they were too obvious, which I doubt, or he didn't know. And so he just wrote what he knew was true. But everything I've discovered comes from brilliant ancient Greek thought. If you're not already a subscriber, become one. Click like, tell your friends about this, tell your teachers, tell your parents, tell everyone you know, and spread the news of this channel so that it can become tops on the web and everybody else can learn what you've just learned from me. I'm John Gabriel. This is New Calculus Channel. Till next time.